Hello students, welcome to Anne's classes. Let's do rational numbers exercise 1C. Exercise 1C is found on page number 18 and we are with the first question, evaluate. What's the meaning of evaluate? Solve what is given here, and here we've been given the operation multiplication. That means we have to multiply these two rational numbers. So here let's write this down as minus 14 by 5 into minus 6 by 7. So how do we do multiplication of rational numbers? We multiply the numerators and get a numerator. We multiply the denominators and get the denominator, and we get a new rational number. Now, if you can cancel a numerator and a denominator, you can cancel and then carry on with your multiplication. So here, look at 7 and 14. We can cancel these two. So let's cancel that. 7 ones are 7 and 7 twos are 14. We have cancelled. Now there's nothing more to cancel in the numerator and denominator. So we multiply the numerators and we multiply the denominators. So when you multiply the numerators, first look at the sign. Here we have minus. Minus into minus is plus. And 2 into 6 is 12. So that's plus 12, or we can simply write 12. And in the denominator we have 5 into 1, which is 5. So what do we have now? 12 by 5, which we can convert to a mixed number. So 12 divided by 5, 5 twos are 10 minus 2. So our mixed number will be 2 by 5. This is our answer. Question 2. 7 by 6 into minus 18 by 91. So here let's write that question down. So we have 7 by 6 into minus 18 by 91. Now here what can we cancel? Can we cancel 6 and 18 first? Yes. 6 ones are 6 and 6 threes are 18. Can we cancel 7 and 91? Is 91 divisible by 7? Let's quickly do short division and see. 91 divided by 7 and see. 7 ones are 7, 8, 9. That means there's 2 left. So that's 21. 7 threes are 21. That means 7 into 13 is 91. So here we can cancel the 7 ones are 7. 7 into 13 is 91. So what do we have left here? The sign there is minus. Then we have 1 into 3, which is 3. And in the denominator, we have 1 into 13, which is 13. So what is our answer here? Minus 3 by 13. Question 3. So let's write down this question. There are two rational numbers, minus 125 by 72 into 9 by minus 5. So first, look at the signs. We can cancel one minus sign here in the numerator and one in the denominator. We can cancel 5 and 125. 5 ones are 5. Here 5 twos are 10. There's 2 left, 25. 5 fives are 25. Then we can cancel 7 and 9 and 72. 9 ones are 9. 9 eights are 72. Now multiply the numerators. So when we multiply the numerators, we have 25 into 1, which is 25. And denominators, 8 ones are 8. 25 by 8, we can convert it to a mixed number. Say the tables of 8 and get a number close to 25. 8 threes are 24. And what is left? 1 to make it 25 and by 8. So 3 1 by 8 is our answer here. Question 4. Minus 11 by 9. Let's write down the rational numbers. Minus 11 by 9 into minus 51 by minus 44. Okay, so here remember we can do cancelling. So here this minus and minus in the numerator and denominator. So we can cancel off that. Now here there's one minus sign, but we don't have another minus sign in the denominator. So that remains there. But we can cancel 11 and 44. 11 ones are 11 and 11 fours are 44. We can cancel 9 and 51 by 3. Okay, let's try that. 3 threes are 9 and here 3 ones are 3. What is left? 4, 5. So that's 21. So that's 21. Now 3 sevens are 21. So what do we have here? In the numerator, we have 1 into 17. 1 into 17 is 17. And in the denominator, we have 3 into 4. 3 fours are 12. 17 by 12. And we have a minus sign here which we will put here. So what is the final answer? Minus 17 by 12. Question 5. Here we have minus 16 by 5. Let's write that down. Minus 16 by 5 into 20 by 8. Let's see what we can cancel. We can cancel 5 and 20. 5 ones are 5. 5 fours are 20. We can cancel 8 and 16. 8 ones are 8. 8 twos are 16. Now let's multiply this. So minus 2 into 4 is minus 8. And in the denominator, 1 into 1 is 1. Minus 8 by 1 is equal to minus 8. So our answer here is minus 8. Question 2, similar question here, it is worded differently. Multiply 5 by 6 and 8 by 9. So let's write that down. 5 by 6 into 8 by 9. So here also we continue with our cancelling. So here we can cancel 6 and 8 both by 2. So let's do that. 2 threes are 6 and 2 fours are 8. Now that's it. We can't cancel anything else. So we're going to multiply the numerators. 5 fours are 20 and the denominators 3 nines are 27. So our answer here is 20 by 27. Question 2. 2 by 7 and minus 14 by 9 we have to multiply. So 2 by 7 into minus 14 by 9. So what can we cancel here? We can cancel 7 and 14. So let's do that. 7 ones are 7 and 7 twos are 14. Now multiply the numerators and the denominators. So here 2 twos are 4 and minus 4. 1 nines are 9. So our answer here is minus 4 by 9. Question 3. Minus 7 by 8 into 4. And we'll give this a denominator 1. Now we can cancel 4 and 8. 4 ones are 4. 4 twos are 8. Multiply the numerators. And the numerator minus 7 into 1 is minus 7. And the denominators 2 into 1 is 2. So our answer here is minus 7 by 2. Question 4, we have to multiply 36 by minus 7 and minus 9 by 28. So let's write that 36 by minus 7 into minus 9 by 28. Now we can cancel the minus sign, one in the numerator, one in the denominator. And is there anything else that we can cancel? We can cancel 36 and 28 both by 4. 4 sevens are 28 and 4 nines are 36. Now multiply the numerators and the denominators. 9 nines are 81 and in the denominator we have 7 sevens are 49. 81 by 49 is an improper fraction. Let's convert it to a mixed number. 81 by 49. 49 ones are 49. Now we subtract. This is 7. 11 minus 9 is 2. 7 minus 4 is 3. So a mixed number here is 132 by 49. So let's write that down here. 132 by 49, which is our final answer. Question 5. Here we have minus 7 by 10 into minus 8 by 15. What can we cancel? We can cancel 10 and 8 by 2. So let's do that. 2 fives are 10 and 2 fours are 8. Now is there anything else that we can cancel? There's nothing else. So we multiply the numerators and the denominators. Minus 7 into minus 4. Minus into minus is plus. 7 fours are 28. And here 5 into 15. 15 fives are 75. So what is our answer? 28 by 75. Question 6. So let's write this down. 3 by minus 2 into minus 7 by 3. First thing we can cancel other minus signs. One in the denominator, one in the numerator. Then we can cancel 3 and 3. 3 ones are 3, 3 ones are 3. Multiply the numerators and the denominators. 1 into 7 is 7 and 2 into 1 is 2. Now let's convert this to a mixed number. 2 threes are 6 and what is left? 1, 7 and 2. So what's the answer here? 3, 1 by 2 is our final answer. Question 3, evaluate. That means we have to solve this. We have to solve what is within brackets and brackets here and add up the two answers. So let's begin by writing this question down first. So what do we have here? We have 2 by minus 3 into 5 by 4, which is our first bracket here, first group that we have here. In the next group, we have 5 by 9 into 3 by minus 10. So this also let's close. Now let's work out what's within this. So here what can we cancel? We can cancel 2 and 4. So 2 ones are 2, 2 twos are 4. So what do we get here? Here let's multiply the numerators. We get 1 into 5 is 5 and down minus 3 into 2 is minus 6. Now let's add up the next part. Now what can we cancel there? I can cancel 5 and 10. 5 ones are 5, 5 twos are 10. I can also cancel 3 and 9. 3 ones are 3, 3 threes are 9. So when I multiply my numerators, 1 into 1 is 1 and in the denominator 3 twos are 6 minus 6. Now whenever you do addition and subtraction, when you have minus in the denominator, you must transfer it to the numerator. So this becomes minus 5 by 6 plus minus 1 by 6. So both the denominators have now become positive. So this is minus 5 by 6. Then this plus into minus is minus 1 by 6. Now here the denominator is the same. So we can write the same numerators also, minus 5 minus 6. Signs are the same. Put the same sign and add 5 plus 1 is 6. Denominator is 6. Now 6 by 6 is 1. So the answer is minus 1. So this is the answer to our first question. Question 2. So here also we have these. Let's write it down. 2 into 1 by 4. So let's give this the denominator 1. So this becomes the first group within brackets. Now on the other side, what do we have? We have minus 18 by 7 into minus 7 by 15. So this is the second group. Question 3. So here also let's write that down. So here we have minus 5 into 2 by 15. So let's give 5 the denominator 1. So this is the first one. And then we minus the second one, that is minus 6, and give it the denominator 1 into 2 by 9. Now look at the first set here. What can we cancel? We can cancel 5 and 15 both by 5 itself. So this becomes 5 ones are 5, 5 threes are 15. So let's write that here. If you multiply the numerators, minus 1 into 2 is minus 2. In the denominator, 1 into 3 is 3. Minus, let's go to the other side. Here we can cancel 6 and 9 both by 3. 3 twos are 6, 3 threes are 9. That's it. Let's multiply the numerators. Minus 2 into 2 is minus 4 and in the denominator 1 into 3 is 3. So here since both the denominators are 3, we don't have to find the LCM. It's the same number, and when the denominators are the same, we can write the same numerators also, minus 4. So let's remove the brackets here. Minus 2, minus into minus is plus, plus 4 by 3. Signs are different. Minus 2 plus 4. So let's put the signs of bigger number, which is plus, and subtract. 4 minus 2 is 2 and the denominator is 3. So what is our answer? 2 by 3. Question 4. Let's write this down. 8 by 5 into minus 3 by 2 plus minus 3 by 10 into 9 by 16. Now here let's see what we can cancel. We can cancel 2 and 8. So let's do that. 2 ones are 2 and 2 fours are 8. Let's multiply the numerators. 4 into minus 3 is minus 12 and 5 into 1 is 5. Plus, let's go to the next one. Now here what can we cancel? Now there's nothing that we can cancel. So we're going to multiply the numerators and the denominators. Minus 3 into 9 is minus 27. And in the denominator, 10 into 16 is 160. So here we have these numbers. Let's write it again. Minus 12 by 5 plus into minus is minus. Minus 27 by 160. Denominators are different, so we must find the LCM of the denominators. Now here, look at the two denominators. One is 5 and the other is 160. Look at the bigger number. Now, is this number divisible by 5? It is divisible, isn't it? Because it's ending in 0. So we can write this number as the LCM. So you don't have to waste time trying to find the LCM of both. We can write this number itself as the LCM. So 160. Now to find the new numerators, take the first rational number. Now let's let's write it here, minus 12 by 5, and multiply this by the LCM, 160. So here let's cancel. 5 ones are 5. Let's take 16. 5 threes are 15. 1 is left, now becomes 10. So 5 twos are 10. So now we have to multiply minus 12 into 32. That is minus 384. So that is our first numerator. Let's write it here, minus 384. And look at the next one. This denominator is 160. Here also it's 160. So we can write this as it is, minus 27. So let's write that, minus 27. Now let's subtract this, that is minus 384 minus 27. When signs are the same, what do? We put the same sign and we add. So minus 384 and 27, we are going to add up these two. 4 plus 7 is 11, carry 1. 8 plus 2 is 10, plus 1 is 11, carry 1, 4. So what do we have here? Minus 411, and in the denominator we have 160. So this is our answer, minus 411 by 160. Question 4. Multiply each rational number given below by 1. We have all these rational numbers. We're going to multiply each number by 1. And we know that when we multiply by 1, any number by 1, we get back the same number. So this is 7 by minus 5. Now look at the next one. Minus 3 by minus 4. We can cancel off the minus signs. Into 1 will give us 3 by 4. Next is 0. 0 into 1 is 0. Here minus 8 by 13 into 1 will be minus 8 by 13. Next one, minus 6 by minus 7. Cancel off the minus signs. 6 by 7 into 1 is 6 by 7. Now, what is the commutative property of multiplication? This is just like the commutative property of addition. Now here, if you have two rational numbers a by b and c by d, when you multiply them, a by b into c by d, now if you change the order, that is you put c by d first and then a by b and then multiply, the product will be the same. That means the answer will be the same. So what does the commutative property of multiplication state? For any two rational numbers, when you multiply, whether you change the order or not, the answer will still be the same. Okay, so this is the commutative property of multiplication, which we are going to use in the next question. So question 5 says, for each pair of rational numbers given below, so we have rational numbers given here, verify that the multiplication is commutative. Okay, so we're going to verify this and see, that is, first we'll multiply in the same order, then we'll change the order and multiply and see if the answers are the same. So here we have minus 1 by 5 into 2 by 9. Okay, we just have to multiply the numerators and the denominators. So minus 1 into 2 and 5 into 9. So minus 1 into 2 is minus 2 and 5 nines are 45. Now let's change the order. Instead of minus 1 by 5 into 2 by 9, let's change the order. So now it will be 2 by 9 into minus 1 by 5. Again, multiply the numerators. 2 into minus 1 is minus 2. 9 5s are 45. So can you see the answer? When you multiplied it one way, it is minus 2 by 5. When you change the order and multiply it also, it is minus 2 by 5. That is, even if you change the order, if the answer is the same, then we have verified the commutative property of multiplication. So you can say that they are verified. So final answer, you should write it this way. Minus 1 by 5 into 2 by 9 is equal to 2 by 9 into minus 1 by 5. So even if the orders change, the answer is the same. So we have verified the commutative property. So here we have 5 by minus 3 and 13 by minus 11. Let's first write the same way. 5 by minus 3 into 13 by minus 11, and let's see what we get. 5 into 13 is 65, minus 3 into minus 11, minus into minus is plus, 3 11s are 33. So here we got the 65 by 33. Let's change the order and see. 13 by minus 11 into 5 by minus 3. So here 13 into 5 is 65, minus to minus is plus, 11 threes are 33. So when you multiply it this way, you get 65 by 33. When you change the order of the rational numbers and multiply, you still get the same answer. So what does that mean? It means that 5 by minus 3 into 13 by minus 11 is equal to 13 by minus 11 into 5 by 3. That means we have verified the commutative property. So let's say hence verified. Here we have 3 into minus 8 by 9. So we'll make this 3 by 1. 3 into minus 8 by 9. Let's do our normal multiplication. Now 3 and 9 we can cancel. 3 ones are 3 and 3 threes are 9. So what do we have in the numerator? 1 into minus 8, which is minus 8. Denominator 1 into 3 is 3. Now let's change the order and see. So minus 8 by 9 comes first this time. Into 3 we can make it 3 by 1. Let's cancel 3 and 9. 3 ones are 3, 3 threes are 9. So here let's multiply the numerators. Minus 8 into 1 is minus 8. So let's write this minus 8. In the denominator 3 ones are 3. So here we have got minus 8 by 3. Here also when we change the order we got minus 8 by 3. That means we can write this as 3 into minus 8 by 9 is the same as minus 8 by 9 into 3. So that means this is the commutative property that we have verified. So we can say hence verified. Question 4. 0 into minus 12 by 17. So that is 0 into minus 12 by 17. Now we know that 0 into anything will give us 0. Now on the other side, let's change the order and put minus 12 by 17 first, and then we multiply this with 0. So minus 12 by 17 into 0 is also 0. So here we have proved that 0 into minus 12 by 17 is the same as minus 12 by 17 into 0. That means we have verified this also. Question 6. Write the reciprocal or the multiplicative inverse of each rational number given below. So these two are the same. Multiplicative inverse is the same as reciprocal. So that means the reciprocal of 5. So this is 5 by 1. So the multiplicative inverse or the reciprocal is 1 by 5. Second one, minus 3 by 1 becomes 1 by minus 3. Here we have 5 by 11, it becomes 11 by 5. Now here multiplicative inverse of minus 7 by minus 8, we can cancel this. Of 7 by 8 becomes 8 by 7. Similarly here we can cancel this. 8 by 7 becomes 7 by 8. Now here 15 by minus 17 becomes minus 17 by 15. Question 7. Find the reciprocal or the multiplicative inverse of these questions, the product of these rational numbers. So first we have to work this out. 3 by 5 into 2 by 3. So normal multiplication, we can cancel this 3 and this 3. So what do we have? In the numerator we have 2 by 5. So that means we have to find the multiplicative inverse of 2 by 5. So let's write that. Multiplicative inverse of 2 by 5 is the reciprocal, which is 5 by 2. Now let's look at the next one. So here we have minus 8 by 3 into 13 by minus 7. So let's write that as minus 8 by 3 into 13 by minus 7. Now we can cancel the minus signs here. Now there's nothing else to cancel. So let's multiply the numerators. 8 into 13. That is 104, and in the denominator 3 sevens are 21. So we have to find the LCM, the multiplicative inverse of 104 by 21. So let's write that. Multiplicative inverse of 104 by 21 is 21 by 104. Question 3, here we have minus 3 by 5 into minus 1 by 13. So let's write that as minus 3 by 5 into minus 1 by 13. Now here also there's nothing to cancel, so we multiply the numerators. So minus into minus is plus, 3 ones are 3. So this is 3. In the denominator we have 5 into 13, which is 65. So 3 by 65. Now we have to find the multiplicative inverse of 3 by 65, which will be the reciprocal, that is 65 by 3. So this is our answer. So the multiplicative inverse is given here. Similarly, we have the multiplicative inverse here and the multiplicative inverse here. Here, if you're required to convert this to the lowest term, you can do so. Similarly, here also. So for now, children, we will stop with this. In our next video, we will continue with the remaining questions. Thank you, children.